Lithium-sulfur batteries are geared towards changing the energy outlook on the planet by providing a more sustainable energy output than current rechargeable batteries. Considering the unending potential of lithium-sulfur batteries, it's almost impossible to understand just why these revolutionary batteries are yet to be commercialized. Today on Super Freaky Science, we'll be showing just what lithium-sulfur batteries could change. Why bother with lithium-sulfur when we already use lithium-ion batteries? Lithium-ion batteries are now being used in almost all electrically driven machines or equipment around the world. The uses of these batteries span across a wide range of appliances, ranging from household electronics to electric vehicles and even applications in large-scale power grid energy storage. Lithium-ion batteries gained popularity in a bid to reduce global carbon emission levels by switching from machines and equipment powered by combustion engines to safer battery-powered sources of energy. However, this global adoption isn't due to the energy outputs, which, however sufficient, is seriously lacking in today's energy-driven world. But their use is simply due to the lack of a more powerful, long-lasting alternative. But the good news is, lithium-sulfur batteries could be the game-changer we've been waiting for. Lithium-sulfur batteries may just be the next big thing when it comes to long-term sustainable batteries, as they are lighter, cheaper, and a lot more potent than the current lithium-ion variants. They are well known for having a high specific density and can store substantially more energy on a single charge than lithium-ion batteries. Some lithium-sulfur batteries have been found to release specific points of up to 500 kilowatts per hour, which is significantly greater than the 260 kilowatt per hour max energy range lithium-ion battery can offer. The relatively moderate atomic weight of sulfur combined with the low atomic weight of lithium makes it a relatively lightweight battery, meaning it would have astronomical applications in electrical machines. Current machines, like electric cars, which require high-powered battery packs, would benefit from such a lightweight battery. And unlike lithium-ion batteries that make use of cobalt, which is not only expensive but is mined using controversial means, lithium-sulfur batteries use sulfur. Sulfur is a lot cheaper than other alternatives as it is readily available as a byproduct of petroleum in the oil and gas industry. In addition to being extremely efficient, producing these sulfur-based batteries would cost almost nothing in terms of manufacturing, as they could be produced in already existing lithium-ion plants and factories. Sadly, as promising as lithium-sulfur batteries are, scientists face one major problem in getting them ready for commercial use. They only last a few minutes at best. History of lithium-sulfur batteries. Although lithium-sulfur batteries have not gone mainstream yet, they have been in use and development for over half a century. These battery types were introduced in the 1960s after a patent for a battery composed of lithium alloys as an anode and sulfur as a cathode was submitted by Ulam and Herbert in 1962. The science behind the batteries was improved a few years later by increasing the voltage up to 2.5 voltage batteries with the addition of organic compounds such as dimethylformide and propylene carbonate. This short-lived battery was used for a few decades until the late 1980s, when work began on developing a rechargeable version of the lithium-sulfur battery. This rechargeable battery was achieved by switching out the solvent for the aliphatic amines used as electrolytes with an ether called dioxylane. These electrolytes were responsible for transferring charges between the anode and the cathode rods inside the battery and were usually organic liquid. Since then, more science advancements and research into lithium-sulfur testing has proved efficient in building batteries with a long-lasting effect. Renowned chemical scientist and engineer Arumuga Manthiam, who led the study into the polyanoid class of cathode materials for lithium-ion batteries, also made advancements to the already existing process of lithium-sulfur batteries. He was able to identify the critical parameters required for lithium-sulfur batteries to be used commercially. To achieve mainstream use capabilities, lithium-sulfur batteries need to have a carbon content of less than 5% and a sulfur loading greater than 5 mg per centimeter cube. It also needs to have a negative to positive capacity ratio of less than 5 in pouch-type cells, as well as an electrolyte to sulfur ratio of less than microliters per milligram. Mantherium also made another important advancement in the development of lithium-sulfur batteries with the use of doped graphene sponge electrodes and microporous carbon interlayers. Why have they not been commercialized? The main problem behind the commercialization of lithium-sulfur batteries is that they cannot be recharged enough times to sustain long-lasting power outputs, as they degrade fairly quickly after each use. The polysulfide shuttle effect is the main problem related to the low life cycle of lithium-sulfur batteries. It causes the continuous leakage of active substances from the cathode within the battery, resulting in degradation. When the battery is charged, lithium polysulfide is created, forming a chemically charged substance known as dendrites, which then leak from the positively charged cathode. These dendrites then diffuse and branch up the negatively charged anode inside the battery. At the anode, these leaked dendrites are reduced to short-chain polysulfides, effectively degrading the anode before diffusing back into the cathode to form more long-chain polysulfides. This leakage and degradation of the anode caused by the characteristic problems faced with lithium-sulfur batteries. It results in low coulombic efficiency, corrosion of the lithium, and the eventual short life cycle of the battery. This polysulfide shuttle effect does more than just corrode the anode within the battery. It also causes a characteristic self-discharge observed in lithium-sulfur batteries. This is a result of the polysulfides dissolving the liquid organic electrolytes when the battery is in a rest state. As a result, a microcontroller as well as a voltage regulator are used during testing of the batteries to avoid accidental discharges during and after charging. Fixing the anode and controlling the accidental electrical discharge would result in a stable lithium-sulfur battery. Still, another problem associated with this kind of battery also needs to be addressed. The sulfur cathode has a significantly lower electrical conductivity and would need an extra mass to get the entire contribution of active mass to the battery. What this means is that a larger cathode and even larger amounts of electrolyte need to be used to improve the power output and life cycle of the battery. Steps towards more powerful batteries. Current ongoing experiments with lithium-sulfur batteries are geared at solving the problems of the shuttle effect and getting a working prototype that can be used for numerous life cycles. Current lithium-sulfur batteries can last as few as 50 rechargeable life cycles. That's factoring in that they don't experience accidental discharge by then. So it's safe to say that they are a long way from being commercially available. Scientists are currently experimenting with alternative forms of electrolyte, like a ceramic-based electrolyte or a hybrid gel-like electrolyte, to reduce the shuttle effect within the batteries. Early this year, a research team announced the use of a sugar-based additive that effectively inhibits the release of polysulfide chains from the cathode within the battery. A successful prototype was able to achieve 1,000 charge cycles and a 700 mAh per gram capacity, which is a step in the right direction for sustainable lithium-sulfur batteries. With a global consensus to reduce greenhouse gas emissions and reduce the planet's carbon footprint, the need for development of more sustainable batteries cannot be overemphasized. With countries like the Netherlands, the UK, and Norway announcing plans for the elimination of gas-powered vehicles by 2050, as well as several automobile companies switching to electric model cars, it's imperative that stronger, cheaper, and most importantly, long-lasting batteries are produced. And it turns out lithium-sulfur batteries are setting up to answer the call. That's it, guys. Let us know what you think in the comments section below, and we'll see you in the next video.